and welcome to this week's 60 minutes even with Scottish Self-Build and Renovation. My name is Gavin Esselmont and I am the host for today's programme. I hope you've all had a great weekend. Weather's been good today. It wasn't so good in Aberdeen yesterday, but hopefully the following week will be just as good. I'm joined today by Mike Bauermeister and Daniel Tweets of Kishorn Insulations. Today we'll be finding out a bit more about spray foam insulation. Mike is going to run through it, the application of spray foam and how it can contribute towards an efficient insulator for both new build and renovated homes. If you have any questions, please put them into the comments feed and we'll pick them up as we go through the programme. We'll wait until the end of the presentation and we'll pick them up then. So without further ado, I'm going to put Mike onto the screen and we're going to have a wee chat with Mike. Hello, Mike.
Hi, Gavin. How are you?
I'm good, thanks. How are you doing?
Yeah, good, thanks. Good.
Yeah, good weekend?
Yep, it's been very productive. Managed to get out on the hill on yesterday, so dodged some showers, got a summit, so very happy.
Where were you?
We're in Cairngorm. We summited Breiria, which is one of the ones to get ticked off. So,
is that how long does that take for the round trip?
We were 5 hours in total.
Okay.
Hoped to try and sneak in a ridge, but the weather was pretty foul, so it was just up and down and back home for coffee.
I guess it can change quite quickly as well. I mean,
yeah, it's a nice place because it can get quite wild, so you feel like you've achieved something.
Is it quite a is it a seasonal kind of walk? Can you do it during the winter if you're careful, or?
Yeah, I'd actually tried it in winter conditions just before lockdown, but it was blowing an absolute hoolie and thought better of persevering and turned tail and headed home. So I was glad to get it done in summer conditions.
The great Scottish weather, welcome to July.
Absolutely. Yeah.
So, Mike, tell us a bit more about Kishorn Insulations.
Yeah, so it's we do insulation. I'll go into a lot of detail in the actual presentation, but we're going from strength to strength. We've certainly seen a big increase in demand for the spray foam. I think as more people become aware of it in terms of architects and contractors, but also just the general public seeing it in neighbours' properties getting done, and seeing our advertisements, speaking to us at the shows that we do, such as your own one, and hopefully this webinar will access a few more people that will see the light that it is the better way to insulate your home.
And have you been impacted by COVID? I mean, that old question. I mean,
yeah,
by the way, I think your colleague Daniel's with you today as well, but we're going to try and do the social distancing as much as we can. So if it is a little bit, if it's a little bit kind of moving chairs, etc., we're trying our best to be compliant. But
So luckily we live quite close and we're good friends. So we've been in a bubble together, which has helped with getting back to work and the run up to getting back to work as well.
It's been quite difficult, really, in terms of the construction industry, and dare I say, common sense comes into it a hell of a lot. I mean, I think it's
absolutely, there's only so much you can do with a 2 meter distance, and thankfully now we're able to use PPE as a control measure, so that certainly helps a lot.
And have you done any installations over the last kind of few weeks, or is it...
Yeah, so we've been predominantly doing new builds and retrofit projects. We're making sure that any properties we go to, customers are happy for us to be there. We're being really strict in ensuring that all of our team aren't showing any signs, and if they are, then we're making sure we put the measures in place so no one's at risk. So we've been very fortunate so far that everything's gone right. So long may that continue.
Great. Okay, well, we're going to have, you guys have kindly put a presentation together, so we're going to kind of put up on the screen and you're going to talk through it. I'd say feel free to ask any questions. It doesn't have to be about the presentation. It can be about your project. One of the main reason for doing these webinars is really so that everyone can learn and everyone can reach out to the help that's out there, irrespective if you're in the middle of a project or just thinking about it, so just please use this session any way that you feel fit. So let me just put the presentation up here and I'll hand it over to you, Mike.
Brilliant, thanks very much. Well, hello there, good evening, and thank you very much for joining us. As Gavin said, my name is Mike Bauermeister and I'm the operations manager for Kishorn Insulations. Tonight we're going to be looking into airtight insulation the key to comfort and efficiency. But first of all, I'm going to tell you a little bit more about ourselves. So we started out as a building contractor on the west coast of Scotland, building energy efficient homes. We knew that the key to energy efficiency was airtightness. However, existing solutions used tapes and membranes, which meant that achieving an airtight building was very difficult. We started searching for a better solution and stumbled across Icynene. That, in short, led us to become the first Icynene contractor in Scotland. That was way back in 2008. Since then, we've become very involved with Robert Gordon's University and in conjunction with Icynene in researching and developing further solutions for insulating properties using Icynene, which has also led us to work a lot with Historic Scotland on a number of occasions. Now, any prospective job will first of all be surveyed by one of our 2 technical surveyors. What will happen is they'll come out and carry out a free site survey, and they'll walk you through the different installation options that would be suitable for your property. Excuse me. And at the end of that, they'll compile a quote for the work. Once everything's been finalised and agreed, it'll be myself that gets in touch with you, and we'll look to schedule the installation. We'll also make sure that everything's ready for when one of our 2 installation teams come out to install the insulation to your property or new build. Now, all the products that we install are both BA and Kiwa certified, and we're obviously a licensed installer of Icynene as well. And we're Green Deal approved, which enables us to install to properties that have received grant funding from Home Energy Scotland and the Energy Saving Trust. We've also signed up to the HICS Consumer Insurance Backed Warranty Scheme. That covers the workmanship of all of our jobs for up to 2 years, as well as a deposit protection scheme. And once the job has been complete, you'll get a 25-year warranty certificate from Icynene. And as I've said as well before, we've done a lot of work with Historic Scotland in insulating older properties that are notoriously drafty. We strive to deliver the best customer service that we can from start to finish, and we really pride ourselves in that. And it's great that we get so many happy customers at the end of their journey. It really kind of makes our job worth doing when we hear that people had a successful and positive experience with us, and also when they see the benefit of their insulation and reduced energy bills, for instance. We categorise the 3 different types of service that we provide as new, existing and historic. All of them are pretty self-explanatory. Obviously with your new builds, we can apply the foam in between studs, straight to the OSB, or in between the rafters, straight to sarking boards. We can also do underfloor or intermediate floors for soundproofing or for further insulation. It's a very positive step using Icynene as your insulation, not only because you get a great airtight product at the end of it, but also it's a very quick installation to take place. Typically, we'll do a kind of standard new build well within a week, and it's for 5 days, including travelling there. The other benefit of using Icynene is the compactability of our kit. So we have a van and trailer that we would take to site. So that's just one rig set up, so specifically tight accesses or small access points, and really benefit our setup compared to if you had lorries with large deliveries of rigid board. Existing properties, again, very self-explanatory. We can apply to loft areas, be that if it's going to remain a loft or maybe looking to convert into a room and roof. Same as the new builds, we can apply to suspended floors or intermediate floors. And also if you're going to be retrofitting out an old stone building with an offset timber frame, we're able to apply directly to the stonework and get in behind that internal stud work, minimising any chance of cold bridging. And again, historic, very self-explanatory. We've worked with Historic Scotland doing many large estate properties, which are inherently drafty and difficult to insulate. We developed this injection procedure with Robert Gordon's University and Icynene, which enables us to drill holes in lath and plaster, inject the material in behind, and we can insulate these old properties without having to remove that traditional lath and plaster. It's a great solution for insulating these properties because it ensures that their original character is maintained. Icynene have a number of products that we have access to, and we always look to make sure that we suit the right product to the right job. Typically, LDC 50, which is our most common open cell spray foam that we use that in the vast majority of the jobs that we install to. The LDP 50, as I just said, is the pore derivative of that open spray foam that we use to inject in behind lath and plaster. There's also LDC 70, which is a slightly better U value to it. So if you're short on space and can't get the full depth with the LDC 50, then we can use that in certain scenarios. There's also a cavity wall closed cell foam, which is exclusively for masonry cavity walls. And also, it's not on this slide, but a closed cell foam, which we can apply to commercial sheds and the like. I'm now going to pass you over to our director, Daniel Treats, who's going to explore tonight's title, Airtight Insulation, the Key to Comfort and Efficiency.
And just while you're changing out there, I'm just going to flash Daniel up on the screen just so that everyone can see who we're talking to.
Good,
Daniel, you okay?
How are you doing?
There we go. Hey, Daniel.
Not too
How
bad,
you doing?
yeah.
Right?
Good.
Good. So just going to crack on with the presentation. I'll just kind of minimize this again. There we go.
So is that me live?
That's you live, yeah.
Okay, well, my name's Daniel. I'm director of Kishorn Insulations, and I'm going to try and deliver the technical aspect of the presentation. So today we're looking at airtightness. Airtightness, the key to comfort and efficiency. So Mike touched on Icynene, the product that we install. But who and what is Icynene? Well, they're a Canadian company, founded in 1986 in Canada. And it's a very, very green product. It uses water as the agent of expansion rather than other harmful gases, contains no formaldehyde or other chemicals like older insulation did in the sort of post-war era. And much like, unlike rigid board, for instance, has a lot of harmful chemicals trapped in the gas. It's an open cell product. It traps air, and that's the form of insulation. It's got a rating of 1 on the GWP index, the Global Warming Potential Index, which is unbelievably low compared to 100 plus for other products. And it's a member of green building organizations across the world. A great example was when it was used in health houses for asthmatics, basically because there's no off-gassing because we don't trap harmful gas, and there's no sort of harmful dust that gets generated. So it was a great insulation for that. For those health houses. The 36, I think that should actually be 34, but significant experience in the spray foam industry. So it's no surprise that they really are the world leader in spray foam technology. It's an air barrier and an insulation which is breathable, which all sounds a bit complicated, but it will stop air and moisture vapor penetrating, but it will allow any actual water that gets in to breathe and evaporate and eventually dry out. It's much like sort of Gore-Tex, which you might be more familiar with. There's a few numbers on there just to show you the standard, and that we sort of beat the standard for the air barrier itself. And so, yeah, Icynene facilitates moisture diffusion and bi-directional drying. It basically just means if it gets wet, it's allowed to dry out and the insulation wouldn't be compromised. And this is just a little map at the bottom, just to show where Icynene is globally. It's used in both hot and cold climates to keep heat either in or out, but it really is a world-leading brand. Can't talk about insulation without talking about global warming. As David Attenborough said recently, insulating our homes is one of the most significant ways that we can reduce carbon emissions and save our planet. If our homes are not insulated, we use a lot more fuel than we need to. We're generating a lot more CO2 than we need to, just because we have leaky buildings, and we need to have the heater on just more and more, because we are ultimately building inefficient buildings. So that's a good point just to remember. Now we're talking about an airtight insulation, which is a relatively new, and particularly spray foam insulation, is a relatively new product to the market. I know it's been around for a long time. Icynene has anyway, but certainly in Scotland, it got introduced maybe around the 80s, a different type, which was very detrimental to buildings. But the new technology of going open cell spray foam is relatively new to Scotland itself, although it's been around in the likes of Canada for a long, long time. But when we're talking about developing new innovative techniques, and we talk about building science, what building science is the study of the response of buildings and materials and people to heat, air pressure, moisture, and sound. And insulation, particularly Icynene insulation and spray foam insulation, really touches on each one of those points. So what I would generally ask at this point, if I had an audience, is what do all these buildings have in common? The response I usually get is they all have walls, windows, they have a roof, they're designed for humans to occupy. But when we're talking about building science and insulation in particular, what they all have in common is that they're all just a box of air. So the reason I say that is because effectively we build four walls and a roof to artificially control our environment so it's the most comfortable for us as humans. The outside air could be very, very low temperatures to very hot temperatures with relative humidity following. And inside, we really want to try and maintain like sort of 20, 22 degrees, maybe a little hotter, depending on what you like. And the relative humidity really should be around 50% because we need humid air to be able to function. Now, what nature wants to do is bring the outside conditions into equilibrium with the inside conditions, which is why we're talking about artificially controlling our box of air. So some of the laws of physics we got to remember back in high school days: hot air rises, just like a hot air balloon. Moisture vapor and energy flow from hot to cold and from wet to dry, not the other way around. And cold air cannot support as much moisture vapor in its gaseous state as warm air. Now this is called relative humidity. When you first touch on it, it sounds a bit complicated, but it's relatively simple. If you look at the bottom there, there's a bit of a sort of demonstration. What it effectively means is what's the percentage of water vapor relative to that atmosphere? So at 20 degrees in the middle here, we have 52% relative humidity. Now, if you take that same quantity of water vapor and you move it down to the left at 10 degrees, you've only got 100% relative humidity and you've hit the dew point, water will start condensing. Or you go the other way and you're at 28% relative humidity at 30 degrees. Now at 30 degrees, you can introduce much, much more water vapor than at 20 or at 10. Now, to put these into like a practical thing, if you go out on a very cold day, the air can be very dry and your lips start to crack because it can't hold as much humidity. If you go out on a very warm day and there's a lot of water vapor in the air, then it's very muggy because the warmer atmosphere can hold more water vapor. And we'll learn in the next slides why relative humidity is quite an important part of building science in terms of insulation. Some other sort of building science basics. We've got energy transfer, we've got radiation, convection, conduction, and the more sort of literal or not as well known mass transfer. So radiation is the sun heating up surfaces like the outside of your building, or heating up things inside your building through the windows. We have convection, which people generally know about. If you look at a pot of boiling water, it gets heated up from the bottom. That hot water rises, cools, and falls back down. That's what we call the convection loop. Same happens with the air. So convection, from a radiator, the hot air will rise, cool, fall back down. And again, that's the convection loop. We have conduction, which is probably the best known method of energy transfer. If you look at a pot, you're heating the pot on your stove. Eventually, that heat's going to transfer to the handle and you're going to burn yourself. That's conduction. And then we have mass transfer. Now, mass transfer is, this example is a pot of boiling water. the energy that's being generated and escaping from heating that water is escaping through steam. And that's what's effectively called mass transfer. It's the transfer of heat through moisture vapor within the air. So the important thing to note here is that insulation, generally, especially in our country anyway, is tested and designed for its ability to resist conduction alone, only conduction. And we'll learn in the next slide why that really doesn't tell you the whole story. And that's called the U-value. So I call it the U-value myth. Now, the U-value is effectively the conductivity times the thickness. So it's really based on the thickness of the material. And what it's testing against is how long does it take for heat to pass from one surface of a material to the other. A U-value will tell you the thicker the material, the better the U-value, the better your walls are going to perform. How they test that in lab conditions is what's called the hot box. They heat one side, they'll take a rigid board, for instance, they'll put that in the middle, they'll heat up one side, energy will transfer through to the other, the time it takes will give you your conductivity, and you can multiply that conductivity by the thickness of the material to generate your U-value. Now, this isn't taking into account anything to do with airflow. When we talk about U-values and trying to better our U-values as we design our building, we'll also start to realize that the conductive heat flow reduction diminishes the thicker you make your walls or the higher that you make your U-values, because it's based on thickness. So if you can see there, about 1, 2, 3, 4, 5, 6, about 6 or 7 bars in from the left, at 0.237 watts per meter squared Kelvin, that's where it starts to plateau out. So when you start adding thickness to your walls to try and get a better U-value, your return is really diminishing. And the problem is that it's not substantially going to save energy. It's not cost effective. Building thicker and thicker walls and not having a more efficient building is obviously not cost effective at all. U-values addresses thickness and thermal conductivity, does not address air leakage or condensation issues or any of the wider issues around the building envelope. The problem for us is that energy calculations are U-value driven. They're legislation, they're in our standards, and they do not give adequate credit for air barriers or other things that we must consider, which makes it very, very hard to introduce new innovative products to the market. Yet we still know that controlling air leakage is a really, really big part of creating an energy efficient home. Now, I just want to say I'm not slagging off U-values completely. It's great that we have a standard that we work to, and it's great that there's onus on designers to build more efficient buildings. But unfortunately, U-values is just not the only thing we need to be considering. So convection, mass transfer, what does all that mean in my home? Well, homes are generally, traditional homes are leaky. They're leaky buildings. And we have various places where air leaks from a building, but in particular, we've got walls, floors, walls, and ceilings, which you can see at the top right, that 31%. So this is where all the air leaks within a building, 31% being floor, walls, and ceilings. Now, air leakage in a building contributes up to 50% of your energy loss, which is a massive number, considering that we don't really design for that, for air leakage. We only design for thickness of material. Now, the reason I was talking about mass transfer and relative humidity is because in our artificially controlled environment, we have a relative humidity of 50–60%. It's that humid air, it's that moisture vapor which is holding the majority of that heat. Because remember, we talked about mass transfer holding up to 4,000 times the heat energy of dry air. So we know that a lot of that heat energy is within moisture vapor within the air. Now, we know that moisture vapor is in the air. We know that's holding a lot of heat, yet we're letting that air escape from our buildings, which is causing a massive problem. And it's really an area that we need to look at a lot more and not just look at U-values. So air leakage in general, there's four rules that you have to bear in mind. Air leakage goes positive pressure to negative pressure. For all air that enters a building, an equal amount must leave. So you have that positive pressure pushing air in, negative pressure and pulling it in through sort of suction. Any that escapes, cold air must rush in to fill its place, or air must rush in to fill its place. If we didn't do this, if we had a building and we let all the air escape and nothing came in to replace it, we'd end up living in a vacuum. Nobody wants to do that. Force on a surface is called positive pressure, and the suction on the other side of the surface is negative pressure. So that little diagram at the bottom, if you imagine that's a wall, that's the way air leakage and pressure sort of goes through the walls. So it's blowing and it's pulling cold air and warm air in and out of our buildings. So air moves in and out of buildings in holes in our building envelopes. Okay, and that's either through wind pressure, a stack effect, or fan pressure. Wind pressure is simple, and we have wind blowing on the side of our building, blowing cold air through the holes in our building envelope, creating a positive pressure on the outside of that wall, and then the negative pressure inside is pulling that cold air in. That's wind pressure. Stack effect's a really interesting one because we learned about convection. So convection is that hot air rising. So if we've got a poorly insulated, leaky roof, that convection is taking that warm air that you've spent money heating, it's rising up through the roof, escaping, and then remember we said for all air that enters a building, an equal amount must leave. So you've got that warm air escaping through the roof, that cold air is then rushing in to fill its place. And then we have fan pressure, which is effectively the same, but instead of convection, it's mechanically extracting air, much like an extraction fan in a bathroom. You're extracting air. Cold air needs to rush in to bring it to an equilibrium. So the reason that we have leaky buildings, and one of the very big reasons that we saw 31% so we said 50% of energy loss is down to air leakage, and 31% of that is through the walls, the roof, and the floor. It's a lot of the time due to scheduling and budget constraints, because it makes it very difficult to guarantee high workmanship every time. Now, traditionally, we use pre-manufactured elements like a glass wool that's been manufactured off-site, or a rigid board that's been manufactured off-site. Now, if we look at that image to the right, the image to the right with the one to the left is the manufacturer's recommendation of how that insulation should be installed. And even in that picture, there's gaps around the outside, but if you installed it like that, you cut your sockets very neatly, you cut your wires very neatly, that's what it should look like. But the reality is obviously incredibly different. So the image to the right shows the reality. People just don't have time to do these things properly, which results in gaps around the insulation and therefore results in air leaking out through the building. Glass wool effectively traps air within the fibers, which is what's creating the insulation. And as soon as you compress that, it's no longer an insulation. It's pretty ineffective. It'll also sag down the wall over time. So glass wool in particular, we're trying to make it stay vertical or stay at an angle within our roofs. But really the only place it can be used reasonably effectively is flat on a ceiling. Some other examples I've seen of poor installation of insulation. This is glass wool, lots of little offcuts to try and avoid wastage. You can see it sagging. There's a general lack of knowledge around the construction industry about how to create efficient wall envelopes. When I went through my trade as a joiner, I know I wasn't particularly focused on achieving a certain standard in insulation. It was really just to get it in there. So, and this is the kind of thing that happens. This is a rigid board, and trying to cut that into place. You see how there's a stud there to catch the plasterboard, and there's a gap behind it. they haven't managed to get the insulation in behind that gap. So that's a big empty spot. The homeowner there has really been ripped off and has been left with a really drafty building. But even if that was filled, you can see the joints. And the reason that's not one sheet is probably because they're trying to reduce wastage by using small little offcuts, and that's the result. One project I saw recently, there was a mountain of offcuts in the middle of the floor. Obviously, we're in Scotland, we build a lot of timber frame homes. And although ideally we'd like every bay to be 600 millimeters and we can just put nice, neat cuts in there, the reality is very different. We've got openings of all different sizes, not to mention wood bows. It's an organic material, it moves in different ways. And not to mention the house moves over time, which means if you have a rigid board or a glass wool and that house moves, suddenly that, even if you had a perfect installation, suddenly it's all off kilter. And the wastage is obviously a massive problem in them. So this is a little bit about vapor diffusion. This is to highlight the problem with letting copious amounts of water escape into your walls. So vapor diffusion is very, very natural, a healthy process through a standard size of gypsum board, plasterboard. Vapor diffusion, just the migration of moisture by moisture pressure internally, will generate about 1/3 of a litre of water over this heating season, which is fine, it's controllable. What we do is try and put VCLs, vapor control layers, behind the plasterboard to try and make sure that water doesn't diffuse into the wall and create problems. Now this is on a perfect sheet of gypsum board. If we go and punch a hole into that gypsum board and to put a socket in there, for instance, now suddenly we have up to 30 litres of water entering that building, and that's a problem. That's a big, big problem. Now, what we try and do is put vapor control layers, but they're obviously very ineffective. Generally sort of plastic sheets that you're stapling in place, but when your electrician comes around and punches a hole in the wall, they don't generally have any regard for the VCL layer. And this is happening in particular because it's no longer diffusing through that material. It's the moisture vapor within the atmosphere. It's that relative humidity within that air. We're allowing that air to escape through holes in the building envelope, much like this plug socket. And that humid air is then escaping into our walls, and it's creating a big problem. We could end up getting interstitial condensation in some places, and effectively causing big problems for our walls. I've seen some examples of building envelopes which all appear fine where the VCL is intact, and then if you take the plasterboard off around that plug socket, you can see lots of mold growth around that plug socket. That isn't vapor diffusion. That isn't actual moisture. That's vapor. That's moisture vapor within the air condensating behind the plasterboard, maybe behind the VCL. So that's why we want to create an airtight insulation. So I'll try and summarize the best I can. So we looked at relative humidity. So we know that within our buildings, we artificially control our atmosphere, and we heat up our atmosphere, and that hot air can hold more humidity. So it's got about 50–60% relative humidity. It's that humidity, it's that moisture vapor that's holding the heat that we're generating. Now, we know that there's lots of holes in our building envelope, and so that heat's escaping through the air and cold air is rushing in to fill its place. And so that is why we need an airtight insulation. And then the other one that I touched on was the moisture within that air. If you're using a product that allows for moisture vapor to enter your wall and then not dry out, then you're going to have problems with mold growth in the inside of your wall, which is a big issue. So if it's an air barrier as well, we also put VCLs on, but in reality, that air barrier is sufficient enough to stop that moist air entering your walls and causing big issues. So hopefully I've summarized. people could have should have questions around this, and then I might be able to go into a bit more detail. But basically, with Icynene, the benefits are we're controlling that moisture vapor, we're controlling that condensation and mold. There's a lot of structural integrity, which I haven't touched on because we're talking about air leakage control, but the structural integrity because the insulation itself adheres to the surfaces that it's applied to, and it's very durable. It improves indoor air quality, the health of the building, the occupant, because we said at the start there's no harmful off-gassing or anything like that. It controls drafts because it's airtight. I think one of our surveyors was on a project recently, maybe last year, and he took a plug socket off just to look behind, and he saw just a bit of dirt hanging, and it was flapping in the wind because there was so much draft there. So something like Icynene will help control that. It obviously improves any energy conservation, so David Attenborough would be very happy. Sound attenuation is very good. It's very good. We had a case study in a hotel where there was an issue between two rooms and it wasn't very good sound qualities, and Icynene really fixed that. And then it's very good for hard to treat areas. So I'm going to flick through a couple of photographs so you can sort of see it in action. So sorry for the poor quality, but this is a good example of a curved roof. So immediately, if you've not got cuboid dimensions, 90-degree angles and flat surfaces, it's very hard for you to fit a rigid board or something like that against these surfaces. Now, in this case, it's sprayed applied, so it fills the area that you apply. And this is a fascinating example because it uses engineering joists, and the insulation is allowed to sit in between all those joists, so it reduces cold bridging as well. So it's got double benefits in this case. Here's just a big project somebody did with Icynene. Again, very, very difficult to treat with other insulation types, but with Icynene, it's an absolute breeze. Also, you're working above your head. You're not having to lift heavy materials. Instead, you're spraying it into place and it's adhering to the structure. Just a typical new build that I think we've done, so you can see what that looks like. And then obviously this is a very organic shape, next to impossible to do with any other material other than a spray foam technology such as this. Okay, well, thank you very much for listening. I'm going to pass over to Mike to field any questions, and if there's anything technical, I'll jump back on and answer.
Thanks, Daniel. That was interesting. It's looking at some of the images you got there. I'm curious as to how, when you spray the Icynene in, what's the finish like? So if you're going to be I don't know, I guess you have to put another layer on top of that, or do you paint?
If it's a new build, obviously there'll be specific UValues that we'd have to hit, that really determines the depth. Generally, we're finding that we'll do a full stud depth of say 145, 150 mil, and then they're needing to add in addition to that a 25 mil board of Celotex in order to hit these UValues, which Daniel's gone into great detail about. With a standard retrofit installation where we don't have a UValue to hit, 150 millimeters is really our magic number for an open spray application. Of course, when it comes to injection in behind wall linings, so your lath and plaster, 150 mil, it's just not possible to hit that. On average, we find that the gap can be anything from 80 mil to 100 mil in these instances. And of course, again, as Daniel said with that example of removing the plug socket and seeing the wind blowing, anything we can put in there is going to greatly improve the thermal efficiency of the building.
And in terms, just a couple of questions before we get stuck into other questions. Just for me, in terms of the actual application, whether it's a new build or an existing home, that actual application, is it quite messy?
Yeah,
is it smelly? Is it toxic?
It is quite messy simply because you're spraying a foam onto a surface. We pride ourselves in keeping things as tidy as we can, so the team fully mask out our work areas. We like to leave things cleaner than when we find it. which has been some positive feedback from a lot of customers who are impressed with that. It is messy, but yeah, it's a small cost to pay for good installation in some respects.
I guess the reality is it's going to be an empty
Exactly,
room or empty house. It's not going to be, you're not going to have furniture in it and all that sort of stuff. It's going to be pretty bare bone as well. So great. No, thanks very much for that, Daniel. That was really good. We had a couple of questions in when we were on the presentation. We also had some come in just before as well. So I'm going to fire these up onto the screen. So the first one that we received was about an existing granite building in Aberdeen. What should we be considering when looking at how to improve the thermal properties of the building? So I guess this question may relate to a cold, drafty granite house. I'm assuming here, but yeah, maybe is there an application that could be applied to an existing house that's 3 stories?
Yeah, absolutely. I mean, it very much depends on what the makeup of the building is. So without knowing specifics, it will be a broad general answer. If we're able to access the underfloor area and it's greater than half a meter of depth, then we can apply to that area. As I've said already, we can inject in behind any lath and plaster wall linings. We are able to inject in behind plasterboard linings, but if there's any insulation in there already, that would obviously have to come out, which involves a lot more work. So it's very rare that we would do that type of installation. But roofs as well. I mean, roofs are really big cold sink areas in properties. You know, as Daniel said, you've got your warm box of air that you're trying to regulate, and you've only got a thin, possibly old, possibly squished layer of glass wool on your top floor ceiling, and then above that, it's a big cold space, as we all know, in our lofts. So by installing the insulation to the sarking boards and the rafters, we're creating a warm roof area, which keeps that loft environment and atmosphere, very similar to other rooms in the property. So yeah, there's a lot that can be done with roof installation, loft installations.
I guess guarantees and the kind of the thermal properties that are created by the proper application of insulation, whether it's the board, whether it's the spray foam. I mean, what do you typically get in terms of a guarantee? Is there maintenance you have to continue doing, or?
Yeah, so the foam itself, because there's no chemicals in it, and the thermal efficiency of that product when it's applied will be the same for the life of that building. And if you compare that to rigid board, it's got chemicals blown into it. Over time, they dissipate and they off gas. So in 25 years, 50 years time, your rigid board will not have the same thermal efficiency then as it did when it was installed. And I don't know if you've ever had an old bit of rigid board and you rub the edges and it just turns into dust and powder. And that's because it's aged and it's just losing its integrity. And because the foam is just trapping air, it can't become bad, basically. But of course, in Icynene we issue 25-year Icynene warranty for all of our installations. In Canada, I think they actually issue it for the life of the building, but we're not allowed to do that over here. It has to be a specific time frame.
Okay, good, thank you. Another question we've had in about the roof space, which we were just talking about there. So how is ventilation with the roof space maintained to a suitable standard to avoid humidity and damp?
Yeah, okay, so partly half answered that one already. So once we've installed to the roof area, as I say, that atmosphere is then very similar to other rooms in the property. As your standard roof is just now, it's a cold roof structure, so you have to have that ventilation in there in case of any humidity build up, so that can allow to evaporate through that airflow. But once we've installed the Icynene to that roof area, it creates a warm roof, so there isn't that huge temperature difference from any moisture-laden air. As it transfers into that environment, it's not going to suddenly saturate like Daniel described with relative humidity. So there's no chance. If there is a build-up, say from a leak or something of that nature, and because of the open cell structure of the foam, that moisture would diffuse through it and evaporate out.
And when we're talking about the roof space, there's obviously the space on some houses, ground floor and below, that void in some of the kind of houses that I've lived in the past. You know, you could lift the floor hatch, you could basically see the ground. I mean, curious where Daniel mentioned that heat obviously rises. Do you need to do anything in the ground floor, under the ground floor? Could that be treated, or?
Yeah, so it is something that we install to. Obviously, in those scenarios, we make sure that we leave the ventilation system open for that area, just for any ground moisture that can come up through there. But yeah, absolutely. I mean, depending is again where the property is, if it's on top of a hill or if it doesn't have any trees or anything around about it, and you're in an exposed location, you've got wind constantly blowing through that soil and ventilation. And as it's blowing through, it's drawing all of that warm air that might be in the property away with it. So it is absolutely, yeah, a source of heat loss as well.
Oh, good. A couple more questions come in. Is someone commissioning the installation to ensure that the efficiency is up to the initial spec? So I guess, do you have a building inspector that comes in, or is there like an Icynene?
Yeah. So what a part of our Green Deal approved accreditation shows that we have to be installing things to the correct standards specified by the manufacturer, and carrying out that quality assurance. So what we do as a company is our installers will take photos of every job that they install to, so we can make sure that everything is as we've quoted, and it's all been installed properly as well. We also do, myself and Daniel will do site visits as well, and we do regular training with our team, with Icynene representatives, to make sure that everything is as it should be.
Okay. Another question here. Regarding listed buildings, are there any restrictions using foam in listed buildings?
So we've not come up against any. As I said, we've done a lot of work with Historic Scotland, and we're on their approved contractors list, so we've installed with their blessing. But I'd say it's always worth getting in touch with them, or to make sure that they're happy with it to go ahead. And it normally involves us kind of having to send forward our procedures and exactly how we're going to undertake the work, and to satisfy their requirements. But because we're not changing the structure or anything of the building, and we're maintaining the character through our installation process, that we generally don't have any issues with that. But always worth getting in touch with them to make sure that they're happy for it to go ahead.
Yeah. Another question in from Fiona, with regard to retrofit. How do you make sure that there is no air leakage at junctions between the walls and the ground floors?
Okay, so when we're injecting into that cavity and say a lath and plaster, we use both products. So we'll use the spray initially to seal the bottom of the wall, and then we'll inject the pour material on top, and we track its expansion with a thermal imaging camera. And with the expansion process, it gives off a degree of heat, so it's really easy and obvious to see where we're installing, and we can make sure that we're getting the whole cavity filled as we'd expect it to be. Just in case we have come up against in the past rogue dwangs in there and bits and pieces that you wouldn't expect in the build-up. So we do that to make sure we get everywhere insulated that we need to get.
And the more traditional approach, using the boards, I guess the problem would exist there as well, perhaps more because of the nature of the rigid boards versus the kind of the foam insulation spray. How would they do it? I mean, would they obviously try and get a tight fit with each of the boards, and then ultimately try and get some sort of seal where there is any gaps, or do the gaps?
Yeah, they generally use tape on top of all the gaps of the board, but again, you've got an extra process, an extra time constraint, for the contractors when they're installing that. So I imagine most of them do, but obviously it's making the job a lot longer. Whereas with the foam, it's a quick squirt of the gun, and you've got everything all rolled up in one. And it's a much quicker and efficient way to install installation.
This is probably a crazy question to ask, but I'm going to ask it anyway. In terms of the actual application of the foam, if you had, let's just say that you're doing a new build and it was a relatively straightforward new build. It's got 4 walls. It's because I'm assuming that we're just putting the foam on the external walls as opposed to any internals. But if you had a straightforward 2 up, 2 down house, how long would that take to apply the insulation across the whole area?
We generally easily do it in 4 to 5 days. And that'll be applying the foam and then trimming it back so it's flush with studs. And if it's a half story above, then again we'd make sure that that's trimmed back to the rafter face and the coombe sections. So it is a very, very quick process. Yeah, it's generally easily 4 to 5 days. The hardest part is if we've got to travel the length of the country.
Of course, well, it's it must be some beautiful kind of drives through Scotland to get to your clients.
Yeah.
I guess just go back to the retrofit. And thanks, Fiona, for the question. In terms of the retrofit, I mean, you mentioned there about injection. Can you go in from outside? Is that typically how that would happen, or?
You certainly could. For the likes of the lath and plaster and the old construction buildings, it's definitely better to do it internal. Because as soon as you start drilling holes externally, you've got a much bigger job to seal it off afterwards. And if there's any delay from a mason coming in behind us, there's always a risk of moisture getting in there, which obviously you want to avoid in the first instance. So from inside, it's always better. But obviously, if it's a block cavity wall, then that would be drilled from the outside, similar grid pattern that we would use internally. Yeah, it's a rarer construction type in Scotland because we've got timber kits with block, and so obviously we can't install that closed cell foam into those wall cavities.
All right, good stuff. That's it just now in terms of the questions. That's been really good. I think in terms of people wanting to get in touch with Kishorn to talk about their projects, what's the best way to do that?
Yeah, so if you jump on our website, which is kishorninsulations.co.uk, scrolling along the bottom perfectly timed, we've got a web inquiry form on there. There's also a lot of information and case studies as well from projects we've done. Facebook as well, we've got some links there to our website and some videos that have got some capturing ability for people's inquiries. We do have a phone line as well, but it's typical of the West Coast. It's intermittent at best, so email is absolutely the best form of getting in touch with us. And as soon as anything comes through, we forward it on to one of our technical surveyors, if it's either East Coast or West Coast based, and they'll give any inquiries a call and a chat, and we can take things from there.
Yeah, and you guys are quite active on Facebook. I've noticed quite a lot of questions getting shared on Facebook, which is great because again, it's not the people asking the questions get an answer, but everyone else is learning from that as well. And I think it's good that you get
one of Daniel's big things is to keep our answer rate high.
Oh, good stuff. Okay, thanks, Mike and Daniel. I really appreciate you guys taking time out.
Thanks for having us.
Amazing. And I am going to introduce our next webinar. It's Tinto Architecture, Interiors and You. They're on it's 9th of August. I was thinking August. It can't be August yet, but it is. It's just next week. So we've got Richard Tinto of Tinto Architecture, Interiors and You. They will be discussing why a self-build or renovation is the best way to upsize. I was having a bit of fun with Richard just a couple of days ago. He's going to try and stir things up a little bit and have a bit of a debate going as well. So we'll see if that happens, but certainly it should be one to watch. That's Sunday the 9th of August at 7 p.m. I'm still surprised it's August next week, but hey ho. Thank you very much, everybody. I really appreciate you guys coming on to watch this. We will be again back in a couple of weeks, and if you've got any questions for Kishorn in the meantime, please feel free to get in touch with them on their Facebook page, on their website, and their good old phone as well. But remember for that West Coast flag. Okay, guys, thank you very much. Take care.
Thank you. Thanks very much.
again. Bye bye.
Bye now. Bye.